Kia ora koutou. This is an excellence question from the 2025 integration paper. It's a differential equation question, and we have to separate the variables in the usual way and then go on to figure out the value of y when x is equal to 2. Okay, so this is the DE here. Oh, it's just going off the screen. I'll get to that in a second. We're given an initial condition, which is that when x is 0, y is equal to 3, and then we have to find the value of y when x is equal to 2. So a pretty familiar pattern. I think the separating the variables and then doing the integration is slightly harder than some excellence questions have been, and you do have to be confident with substitution. Well, at least that's how I did it. The other thing I wanted to say is that I've done two different methods here, two slightly different places where we do the substitution. So if you're just watching this to see how you went in the 2025 exam, I'm sure you're just going to watch one of those methods. But if you're watching this and you're in my 2026 class, I'd like you to make sure that you watch right till the end and go through both of the different ways and see how they end up getting you to the same place. Okay, so finally, let's get into it. I'll start out by just writing out the DE as usual. So we have y minus xy minus 1 plus x dy by dx equals 0. So I'm going to go quite slowly here because we don't want to muck up this separation of variables. So I notice that I've just got the y stuff in here. So let's factor out a 1 minus x and then set that equal to 1 plus x times dy by dx. So now the separation of variables is pretty obvious. We're going to have 1 minus x over 1 plus x dx is equal to 1 over y dy. And we're going to integrate both sides. Now the tricky bit in here is going to be on the left-hand side. The right-hand side is pretty easy. The thing that I did here that you might find slightly different from what I usually do is that instead of putting the constant on this side, I've worked it through and I've put the constant on this side. Now, it won't matter. It will all kind of wash out in the end, but it just felt like a slightly easier thing to do. If you did it the other way, then obviously that's cool. But that might be why your intermediate steps look a little bit different from mine. So I'm going to take the left-hand side and just work with it off here instead of working with the whole thing. If we start off by just looking at what we've got, we don't have a very nice pattern, right? So I've got the denominator here is 1 plus x, and the derivative of that is 1, but I've got all of this stuff up here with the 1 minus x. So I'm not loving that. And that means that we're going to use, we want to be able to simplify that left-hand side. Okay, so I guess the first thing that we could do here is we could try a u substitution, because if we can change this out, we might be able to divide through, and that works quite well. So method 1 for doing this problem is I'm going to do a u substitution now, and we're going to say let u equal 1 plus x. So du by dx will equal 1, and that means that du is equal to dx. Right, we now have to work on that 1 minus x. So u is equal to 1 plus x. That means that x is equal to u minus 1. Our goal is to get an expression for 1 minus x. So negative x is equal to 1 minus u, and then 1 minus x is going to be equal to 2 minus u. So that means that I'm ready now to go ahead and do the substitution, because I've got all the bits are now in terms of u. So this thing here suddenly looks much nicer. I've got 2 minus u over u du. And we can split that up further as 2 over u minus 1 du. So let's put that all back together. Will I put back together? No, actually I did the integration now. So we get 2 times the natural log of u minus u plus c. And I'm going to sub everything back in terms of x. So that's my left-hand side. All right, so let's put everything back together. We've got 2 times the natural log of x plus 1 minus x plus 1 plus c is equal to the integral of 1 over y dy. Now, because I put my constant on the left-hand side, that means that here I'm just going to have the natural log of y. Right, so we get down to here. And now we're going to substitute in when x is equal to 0, y is equal to 3. So we've actually done most of the hard work in the problem now. Substituting in, we get 2 ln of 1 minus 1 plus c is equal to the natural log of 3. This is 0, so we get c is equal to the natural log of 3 plus 1. So we've got this, and now we're going to plonk this back into here and get our final thing. So 2 times the natural log of x plus 1 minus x minus 1 plus ln 3 plus 1 is equal to the natural log of the absolute value of y. Now, happily, we've got the minus 1 and the plus 1 go away. So we're left with 2 times the natural log of x plus 1 minus x plus ln of 3 is equal to the natural log of y. And our job now is to substitute in when x equals 2, what's y? So we don't have to get an expression for y, we don't have to e both sides, everything, or anything like that. We can just go 2 times the natural log of 3 minus 2 plus the natural log of 3 is equal to the natural log of y. And that gives me 3 ln 3 minus 2 is equal to the ln natural log of y. Doing a bit of rearranging on the 3 ln 3 gives me this. And now to get the y value, we'll do e to the ln y is equal to what? What have we got? E to the ln of 27 minus 2. I'm going slower than many of you will have gone in the exam, just to make sure that people watching next year can see all of the steps. So we can split this up into e to the natural log of 27 times e to the negative 2. And I'm getting 27 e to the negative 2. I'm just trying to think about whether y could have been either a positive or a negative. So I'm definitely getting y is equal to 27 over e squared. I actually haven't really turned my mind to whether it works if y is equal to negative 27 over e squared. Right, I'm going to think about this out loud now. So this is going to be kind of loose. Let's have a look. What have we done? Yeah, I think y could be equal to plus or minus that. I'm sure someone out there, possibly a maths teacher who likes to leave comments on my videos, is going to tell me if I've got that wrong. If you're going to tell me that I've got that wrong, can you please do it nicely? All right, but that's where I got to. Now, I'm going to show you another way to do that with a slightly different substitution, because I think some of you might have gone down a different pathway all the way back here. So when I looked at this here, I went straight away to letting u equals 1 plus x, and then I did the split up. But the other way to do it, especially if you've done quite a lot of partial fractions work, which if you're doing scholarship or Cambridge you will have, is to try and do a little bit more like stuff on this before you do your substitution. So I'm going to work right through this now. If you're in my 13 MCA class next year and you're watching this in 2026, I want you to make sure that you're confident with both of these methods, even though they're basically the same thing. It all comes back to be the same in the end, so I'm just going to redo one part of it. So if I'm looking at 1 minus x over 1 plus x dx, usually the way that I would do it is I would force in that 1 plus x up the top, and then I would take out 2x. And if I do that, I'm going to get 1 whole minus 2x over 1 plus x dx. And that 1 is very easy to integrate. I get x minus, now we're working with 2x over 1 plus x dx. Now I'm still going to go off and do a u substitution, but the constant comes out slightly differently, and I think it's quite cool to just have a look at how it all works out. So if we go let u equal 1 plus x, u minus 1 is equal to x. 2u minus 2 is equal to 2x, right? Because I'm trying to match this, and then lastly I've got du by dx is equal to 1, so du equals dx. So when I chuck all of that into my integral, we get that equals x minus 2u minus 2 over u du, which gives me x minus 2 minus 2 over u du. So when I work this through, I'm going to get x minus 2u minus 2 ln of u plus c. Substituting everything back in gives me x minus 2 times 1 plus x plus 2 ln of 1 plus x plus c. So that gives me x minus 2 minus 2x plus 2 ln of 1 plus x plus c. And that gets me to 2 ln of 1 plus x minus 2 plus c. Right, so I'm just going to highlight that line. So this is where we get down to on the left-hand side doing it with that substitution. And I just want to highlight the difference with what we got earlier. So if I shrink all of this, so way back up here, we had this line here for my left. Oh, what did I just do? I don't know what I did. There we are. We had this here. So it was out by 1, right? So down here, the old version gave me 2 ln 1 plus x minus 1 plus c. Right, so what happens when we work it through this way is that the plus c that we're going to get in this substitution will be 1 off the plus c here, and then from there it all works out. Okay, I hope that made a little bit of sense. I'm trying to balance using these videos just to show people who've sat the exam how they went, and also using it for some teaching for next year's students. Email me or leave me a comment if there's any of the level 3 questions you desperately want me to do next. Otherwise, I'm probably going to keep on going with integration and then complex later on today. Thanks for watching.